In this video, we are going to look at long division, synthetic division, and the remainder theorem. So starting with this first problem, they're asking us to divide using long division. So my divisor in this case is x minus 2, and we're trying to divide that into the polynomial 4x to the fourth. Now you'll notice there is not an x cubed term, so if there are missing terms, you'll fill in with coefficients of 0. So we'll say plus 0x cubed minus 4x squared plus 5x. And then again, there's not a constant in this case, so we'll just fill in with a constant of 0 so that we have every power of x accounted for. Okay, so to start out with, we're only going to look at the leading part of this divisor, and we're going to ask ourselves, what do we have to multiply x by in order to get 4x to the fourth? And so we would need a coefficient of 4, and we would need an x to the third power. So now we're going to multiply that by both terms of the divisor. So x times 4x cubed would give me 4x to the fourth. Negative 2 times 4x cubed would give me minus 8x to the third. Now, just like with long division with numbers, you're going to subtract this particular product. So you do the same thing with polynomials. So this would be a minus, and then when you subtract this, that would make it a plus. So notice that term zeroes out, and you're left with a positive 8x cubed. Bring down our next term, so minus 4x squared. And again, we are only going to focus on the leading term of the divisor and the leading term of what we're trying to divide it into. So you're going to ask yourself, x times what would give you 8x to the third? And in this case, we would need a coefficient of 8 and then a x squared. And now we'll multiply that by both terms of the divisor. So 8x squared times x is 8x cubed. And then minus 2 times 8x squared would be a 16x squared. And now, once again, we're ready to subtract that product. So that'll make this a negative 8x cubed. And when we say minus negative 16x squared, that makes that a positive. So this zeroes out, and this time we're left with positive 12x squared. We bring down our next term, plus 5x. So now we are once again looking at only the leading term of the divisor and the leading term here. And we're asking ourselves, x times what would give me 12x squared? So I would need a coefficient of 12 and then just a single x. Now we'll multiply by both terms of the divisor. So 12x times x is 12x squared minus 12x times 2 would give me a 24x. And we're ready to subtract that product. So that makes this negative, positive, cancels. Here we're left with a 29x, and we bring down our last term of 0. So now we are focused on just the leading term of the divisor and the leading term here. So x times what would give me 29x, so that would be a plus 29. And then when we multiply by both terms, 29 times x is 29x, and then minus 29 times negative 2 would give me 58. And then we subtract both those terms of the product, so minus, plus, that zeroes out. So notice we have a remainder of 58. So when we write our answer, we're going to take our term up here, the polynomial 4x cubed plus 8x squared plus 12x plus 29, and then you take whatever your remainder is, so 58 is the remainder, and you put it over the original divisor, which was x minus 2. So this is called the what they're referring to as the quotient, the q of x. And then this part is what they're referring to as your remainder, r of x. Okay, on the next problem, they want us to divide using synthetic division, and then we're going to talk about the remainder theorem to talk about the value of the indicated function. So whatever value of x they're asking you to evaluate the function at, we're going to use that value for synthetic division. So we'll put it in a little half box. And then out next to the box, we're going to take the coefficients in order from highest power to lowest. So if you do have a missing power of x, be sure you fill in with coefficients of 0. In this case, I don't have any missing powers, so I'll just put those out to the side. And then with our synthetic division, we always bring the first term straight down. 6 is 6. Then we multiply it by the box. 6 times negative 2 is negative 12. And notice I put that answer in the next column, and I will add it to that term. So negative 12 plus negative 2 is negative 14. Then I go back to the box, and I multiply. Negative 14 times negative 2 is positive 28. Put it in the next column, and I add. Negative 7 plus 28 is 21. Back to the box to multiply. 21 times negative 2 is a negative 42. And then I add. 3 plus negative 42 is going to leave me with a negative 39. Now, this number in the last column represents the remainder if we were to do the long division like we did before. The numbers here are going to represent your quotient. So if this started out as 6x cubed, this is now 6x squared minus 14x plus 21. So there would be your q of x. And of course, this is your r of x, where you could, if you had to write it, you'd put it over the original divisor, which in this case, the divisor would have been x plus 2, because it's always x minus your x value, and that's how it becomes x plus 2. But bottom line is, the remainder is also the value of the function at that particular x value. So we would know that when they ask me to evaluate the f of negative 2, if I were to plug negative 2 back into this function everywhere I see an x and punch it out, then I would get an answer of negative 39. So not only is it the remainder when you're doing division, it is also the value on the graph. So if I were looking at this graph, when x is negative 2, my y value is negative 39. So that's the connection between a remainder when we're dividing and the actual y value on the graph.